Alright, today I want to talk about total surface area. Total surface area. Now this is not a difficult concept, but it's a concept that we're so used to dealing with area of two-dimensional plane shapes. Total surface area is a slightly more complicated concept, but it's not too much harder than working out the area of any object. It just requires a few more steps because we are in this case dealing with 3D objects. So I want to start off by drawing a three-dimensional object. So here is I'm going to draw just a box over here. There we go. As best I possibly can. I'm going to make it three-dimensional, putting in my 3D. It's not perfect, but you get the general idea of that. So this is my three-dimensional rectangular prism. Okay, now I want to place in some dimensions. So if I put in some lengths, so let's put a width in. I'm going to say that that's 2 centimeters. I'm going to say that this is 5 centimeters, and I'm going to put in a height, and my height is going to be 1 centimeter. Now the easiest way of working out the total surface area of any object is to work out the object's net. What the net is when you open up the figure and you make the three-dimensional object a two-dimensional shape. So you work out its two-dimensional representation from its three-dimensional figure. So if I draw its net over here, basically you just got to imagine that you're cutting along a few of the edges to open up everything so it becomes flat. So if I try to visualize that, what I get is that's the back part, that's going to be the bottom, this is the side flaps over here, and then we've got another, that's the front panel, and this is the top. Okay, so if we're looking at the bottom part, our bottom part is here, so in this shape it will be here. Okay, so now that we've got our bearings, we can start putting the rest of our lengths in. So that would make this one here 2 centimeters, this here would be 1 centimeter, and this would be our side, which would be 5 centimeters. Okay, so what I'm going to do first is I'm going to label the identical faces. So if you look at the prism, obviously you've got the two opposite faces are going to be identical in length, width, so therefore identical in area. So I'm going to do those in different colour. So if I let's do the side panels. So I'm going to do these side panels, and these side panels will be identical in area. So I'm going to say that the orange areas are going to be both the same. So the way I'm going to represent it would be 2 length times width. So basically what that means is I'm working out the length and width so I'm working out the area using length and width of one of the faces, and I'm multiplying it by 2 to get both of them together. So I'm going to then do, let's do the bottom and the top. So the bottom and the top, I've already shaded the bottom in red. I'm going to shade the top in red. This will have an identical area to the bottom. And I'm going to do that, let's say, in this colour. And that's going to have an identical formula, because the formula for a rectangle is length times width. If we work out the area of one of the rectangles, we have the area of the other rectangle, so we just double it, or we multiply it by 2. Our final colour, let's do in yellow. So this will be the front and back panels. So front and back panels over here. I'm going to do those in yellow. So it will be area 1 equals 2 length times width, like that. So the final thing would be to add all of the lengths and all of the dimensions in of that net. Now we've got the lengths and widths of the yellow areas, the front and back panels. Now we've got the sides as well. In actual fact, we've got all of them. We don't really have to put all of the lengths and widths in, but let's do it anyway. So we've got the ones for the yellow, we've got the ones for the orange, and let's look at the ones for the red. Now, folded over, this red, well, knowing that this one is going to be 5, that means that this is also going to be 5 centimeters. Knowing that this one is 2, this one over here, we know that this one is going to be 2 also. So now we've got all of our lengths that we need to work out the area of our rectangle. So let's start by substituting in our values. So for the orange rectangles, we've got a length of 5 and a width of 1. So we have 5 times 1, and that's going to give us 5 times 1 is 5, obviously, times 2, so that's going to give us 10 centimeters squared. Okay, so that's for our orange. For our red, we've got a length of 5 and a width of 2. So we have 5 times 2, that's going to give us 10. 10 times 2, that's going to give us 20 centimeters squared. And finally, for our yellow, we've got a length of 2 and a width of 1. So we've got 2 times 1. 2 times 1 is 2, times 2 is 4 centimeters squared. Now, total surface area is really just all of those surfaces added up together. So when you're looking at the total surface area of those 3 areas, A1, in orange, I really should have numbered those different, but the orange area, the red area, and the yellow area, we get our total surface area. And in this case, find room for this, so our total surface area in this case is going to be all of these areas added together, which is going to be 10 plus 20 plus 4, which is going to give us 34 centimeters squared. And that's the best way of doing total surface area. You can sort of look at your three-dimensional shape and try to work it out without opening it up and finding its net, but I like to work it out using the net. It takes a little bit of time because you have to draw the net, but at the end you'll save yourself a lot of hassle with trying to work it out using the three-dimensional shape. So that's how you would do surface area.